Hi everyone, welcome back to the next video in our video series. And this algorithm here is called Josephus Problem. And this is an extremely popular algorithm in mathematics and in computer science. And this algorithm is pretty much an algorithm that counts down and solves a problem by executing each and every prisoner until there's only one left. And so let's read the formal description here. The Josephus problem is a math puzzle with a grim description. The n prisoners are standing on a circle, sequentially numbered from 0 to n minus 1. And so an executioner walks around the circle starting from prisoner 0 and removes every kth prisoner and kills him. And I know in this GIF right here, it pretty much shows the prisoners killing off each other, but the fundamental concept is the same, in which there's only one prisoner left in this circle by the end of the algorithm, and basically saying that the rest of the prisoners are cut off and only one survives. To visualize this conceptually, let's say that in our problem we have 10 prisoners and the kill counter is equal to 3. And basically we have 10 little prisoners here, happy prisoners, all in a circle around this table. And we're going to start at prisoner number 1. So in this problem, we're going to start at prisoner number 1. And for every third prisoner, we're going to kill him off. So we're going to say 1, 2, 3. So it's going to be kill equals 3, kill equals 3, kill equals 2, kill equals 1, kill equals 0. This is where we kill off prisoner number 3, because it's 3. It's 1, 2, 3. We're going to kill off every third prisoner in this problem. And then we're going to have to reset the kill counter back to 3, something I'll explain when we actually solve the algorithm. The main point is actually, after we kill off the prisoner, we do it again. 1, 2, 3. We kill the 6th prisoner off. Then we do it again. 1, 2, 3. Now prisoner 9 is dead. And we keep going around this table until there's only one prisoner that survives from this execution. And so the fundamental core and the fundamental problem of this algorithm is pretty much saying which prisoner survives. And so for this problem, given any number of prisoners that we enter into the function parameter, and given any kill counter, which is the which prisoner we have to kill that's greater than 0, find out which prisoner survives from the execution. So that was the end of our little animation or visual demonstration. And now we're going to actually solve this algorithm together in practice. And so this problem, we explained this problem, and pretty much before getting into the more nitty-gritty stuff, let's actually create the prisoners first for this algorithm. So create an array with the prisoners' numbers. So let's actually create an array here called let prisoners equal to an empty array. And let's create a simple for loop here that I equal to 1, I is less than or equal to init, I plus plus. And we're going to just say prisoners dot push, and we're going to push the iteration value. And so if we console.log the prisoners array, we're going to have an array from the numbers 1 to 30. And that's exactly what we want, because we want to first map out the prisoners in number. And so let's actually figure out what we're going to do to solve this algorithm. As we saw from the visual diagram, we have a circle of prisoners. In this case, we have 30 prisoners all in a circle. And we're going to have to kill off every third prisoner. And in this problem, if you kill off every third prisoner and loop through this data set once, you're pretty much killing off 10 prisoners, because every third prisoner in a data set of 30 is about 10. And we want to kill off basically all the prisoners and leave only one remaining. So my intuition here is that we're going to need a nested loop to solve this problem. So we're going to say outer loop keeps looping until one prisoner left. And now the inner loop is going to be the fundamental algorithm here, the algorithm that actually kills off each prisoner at the kill counter. So inner loop executes kill prisoner. So the inner loop executes the kill prisoner. So if we're starting at 1, we're going to execute number 3 in this problem, number 6, number 9. And so the inner loop is going to be in charge of the actual killing. And so before we do the outer loop, let's actually solve the inner loop first, because that's really the core of the algorithm here. And let's actually, let's see here. In order to solve this problem, I'm going to create prisoners filter equal to. We're going to create a prisoners filters array to have like a filter criteria for the prisoners. I'll show you what I mean in just a second. And so let's also set a kill counter not equal to this, equal to this, but separate variable from the function parameter. Let kill counter equal to kill. And so let's actually write the algorithm here for let I equal to 0. I is less than prisoners dot length I plus plus. So what we want to do for each iteration of the algorithm, is we're going to want to decrement the kill counter variable here. So kill counter minus minus. And so basically the next step of this algorithm is we're going to check to see if this kill counter is equal to 0. Because if it is, we're going to have to push that value into the prisoners filters array, because we're going to have to kill off that prisoner eventually. So let's set an if condition. If kill counter is equal to 0, we're going to want to say prisoners filter dot push prisoners of I. And we're also going to want to reset the kill counter back equal to the kill. Because like we said in the visual diagram, we're going to have to keep on resetting this kill counter back equal to, in this case, 3, in order for the executioner to continue killing the third prisoner in this case. And so if we console.log prisoners filter, let's delete this because we know that that is working. And if we look at the prisoners filters array, we see 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And so these are prisoners that are pretty much dead. And so we're going to have to filter them out of this prisoners array in order to make the data set accurate. So let's actually filter out prisoners array from prisoner filter criteria. So let's go down here. So we're going to say prisoners is equal to prisoners dot filter, and we're going to return not prisoners filter dot includes the prisoner. And so basically what this is doing is pretty much filtering out the values of this array from the prisoners array, which is exactly what we want, because we killed off all of these prisoners already. They're just not reflected in the final data set. So we're going to have to kill off these and remove that from the real data set, which is our prisoners array. And so as we could see here, like only a couple of prisoners have been killed off, and we're trying to kill off all of the prisoners except for one. So we're going to have to wrap a while. We're going to have to put this for loop inside of a while loop. While prisoners dot length is greater than 1, then we're going to put this into that. And we're also going to have to put this logic here. put this logic here. There you go. It was lagging because I put this while condition without filtering out the prisoners array. But now everything should be working perfectly. So if we look at the prisoners array, we're left with one item in the array, and 29 is the prisoner number that survives from this algorithm if there's 30 prisoners and the kill counter is 3. And the final thing we're going to do is we're going to just return prisoners of 0, because that's going to be the final value, and that's going to be the prisoner that survives from this execution algorithm. So if we run the test here, everything is working splendidly. So thank you for watching this algorithm. I hope it was mildly helpful for you to some sorts. I know that these kind of algorithms can seem sometimes pointless and boring at times, but I can guarantee you that if you get good at solving algorithms like these, especially as a beginner, like your code and your like application building skills would just improve drastically, because these problem solving skills are really at the core fundamental of what coding is all about. And so thank you so much for your time, and I'll see you next time.